Hi, welcome to Math at Quarks. In the previous episode, we've demonstrated how to find the exact value of sine 18 degrees using the golden triangle. This time, we will solve the problem again with pure trigonometry derivation. Pause here if you want to give it a try yourself. If we use theta to denote 18 degrees, we have 5 theta equals to 90 degrees. If we rearrange the equation, we have 2 theta equals to 90 degrees minus 3 theta. Applying sine to both sides of the equation, we have sine 2 theta equals to sine 90 degrees minus 3 theta. Sine 2 theta equals to 2 sine theta cosine theta, and sine 90 degrees minus 3 theta equals to cosine 3 theta. So we have 2 sine theta cosine theta equals to cosine 3 theta. Next, we work on cosine 3 theta. With the sum formula for cosine, we have cosine 3 theta equals to cosine 2 theta cosine theta minus sine 2 theta sine theta. We can replace cosine 2 theta with cosine theta square minus sine theta square, and sine 2 theta with 2 sine theta cosine theta. Then we have cosine theta cube minus 3 sine theta square cosine theta after simplification. One step further, we can replace sine theta square with 1 minus cosine theta square, and eventually we get 4 cosine theta cube minus 3 cosine theta. Just to recap, here are the two equations we have derived, from which we know 2 sine theta cosine theta equals to 4 cosine theta cube minus 3 cosine theta. We know theta is 18 degrees, hence cosine theta is not equal to 0. So we can cancel cosine theta from both sides of the equation, and we have 2 sine theta equals to 4 cosine theta square minus 3. If we replace cosine theta square with 1 minus sine theta square, we can get 4 sine theta square plus 2 sine theta minus 1 equals to 0 after simplification. Solving this quadratic equation, we have sine theta equals to minus 1 plus or minus root 5 over 4. Again, we know theta is 18 degrees, and hence sine theta is greater than 0. Therefore, sine 18 degrees equals to root 5 minus 1 over 4. Done! Thanks for watching, and you can subscribe to stay tuned. See you in the next episode.